Okay, good evening everyone. I am Shiv Prakash, Research Scholar, Department of Electrical Engineering, IIT BHU. Let's start the session for today. Today's topic is the application of the PV panel. All of you know about the PV panel. Suppose it will give the supply output. You connect to the DC load directly, or if you want to connect a AC load, then you should requirement of a converter, like an inverter, to convert the AC DC signal to the AC. Okay, so I'm not saying something. Let's recorded video of this session as soon as possible because tomorrow is the last date for submission of assignment. Okay, okay, okay. After this session, I will upload the video. For the AC load, you have to convert the DC voltage to the AC by inverter, and another also there is a problem where the DC voltage fluctuation because of the PV panel, yeah, fluctuation because of the sun insulation is changed day by day, morning to evening. That's why the voltage also change. Then you should have requirement of a converter to stabilize the voltage also. But you want to connect a load directly, that you can't be connected. But you, for the low voltage variation, you can connect to the load. Load may it will be PV, and if the load is not working or not operating that time, you have not requirement of the power, then you can store the same power into the battery. The problem in voice, now it's okay. Now it's okay. Yeah. Fine. Load, you know about the load of DC load. There are many type like a PV connected to the grid, and some other is like a water pumping. Know about the irrigation of the land. It will used by the farmers mostly for irrigation of the land for the wheat and another thing, vegetable, a lot of thing. There is a needed of the water supply. Then you can use it directly PV panel and connect it to the a motor, a DC motor, which will rotate and give the auto supply from borewell and other thing, you can use it directly by using a simple converter. Second, for the cooling purpose, for heating. As you know about the heating is like boil the water and or washroom like that. You simply use the solar PV system to get the supply, and it will use in daytime. But some another way you can use or give the supply to the grid like that. Suppose you have a home appliances and you use the PV panel here on top roof of the top roof of the home appliances. This is the grid connection. We take a supply for the home appliances when the or solar is not available, and some other way if you want to give a supply to the grid when our appliance is not working, that then the remaining supply of the so PV panel you can give the to the grid system also. Here the watt meter can use or watt meter for a load which one taken from the grid, and another watt meter you can use for the PV system. If a watt meter for a load, same thing if you for the PV, then you have a zero of the or a unit charge of electricity because of you taken a same supply uh, from the grid and you supplied to the grid also by the solar panel, then you have only we have a zero charges, you can say electricity bill as zero for them. But some areas if you taken a supply from the grid, then they sell you by like a 5 rupees per unit bill, electricity bill. But same thing if you want to supply to the grid same power like that, another power, they will give you only a 3 rupees per unit. It means you taken from you only 3 rupees per unit, and but they will give you they will sell you out as 5 rupees per unit in some way. In that way, if you want to give taken a 0 unit of a electricity bill, then you supplied the more power to the grid from our cell, solar cell. But this is a different thing. Simply you can take a solar panel on your rooftop, then you can use this one. Let's start some questions related to this. First question is which of the following statement is true regarding SLI, starting, lightning, and ignition batteries? In as you know about the vehicle, two-wheeler vehicle or two-wheeler, four-wheeler like that, there is a battery and a self to start the battery. Then when you will going to start the battery, at that time when you push the switch to start the self switch to start the vehicle, at that moment it will take a large of current at this time, the time that battery is known as the SLI battery, which one given a high current in short duration of time. It means for a high current, suppose you have a 12 volt battery, then the power, you know about the power is V into I. Then at that time, to starting like SLI say, it means starting, lightning and ignition. Same thing. For the starting, same thing, it will take a high current. Then your battery should be high power battery. High power, high energy. Both are different thing. High power, it means you they are requirement of the high power at a moment. Like if you same voltage 12 volt battery, but current is known as like a 100 ampere current. 12 volt into a 30 ampere current, like that. If you taking a 30 ampere current for the uh, same rating of the battery, like a 20 Ah battery, it will provide a 20 Ah 20 ampere in a hour, but you need of the 30 ampere at the moment. Then that battery should be discharged at that rate also. Uh, those batteries different battery, not a normal battery which one using in the uh, average load, like a 5 ampere 10 ampere, this is depending on the C charging of the capacity rating. I think all of you know about the C rating. It is depending on the C rating. You know about the power, energy, and voltage and current. These are the parameters related to the electrical system. You know about all of things: power, energy, weight, voltage, and current. And for the battery, you know about the high power, high energy. Both are a different thing. But suppose you use a same rating of the battery for a high power and high energy. Like you have a 100 years of battery capacity of a battery, like 100 years. But if you use the high power and high energy, then what is the mean of high power and high energy? In case of a high power, it means a short duration of a time battery should supply the large amount of current. That battery is known as the high power battery. But at the same time, high energy battery, it means average current. The battery supplied the long duration of the time. That battery is known as the high energy battery. Like you know about the capacitor. No, battery is mainly battery have equivalent circuit diagram like that. Some behavior of the battery also match to the capacitor, like that. VOC is the internal resistance or not. R1 C1 have the dynamic resistance and capacitor. This is the terminal voltage. And all of you know about this one, equivalent circuit diagram of the battery. And you know about the voltage versus time graph, like a full charge VOC. uh, I written as the V rated. It will be displayed like that. sinusoid going to the zero voltage. I can say this is the zero SOC. This is the full SOC. This is the graph of the voltage versus time. But same thing, it will take a large amount large time to discharge the battery because of the high energy density battery have a discharge current is very low, and you can say as a average discharge current, and will take the large duration of time to discharge the all battery. But in case of capacitor, capacitor will charge like that and discharge like that. This will be T charging, this will be T discharging, voltage and time. And this thing is known as the time constant. It will take a same thing, time constant taking to charge the capacitor depending on the time constant. Time constant you know about RC. If C in microfarad, then what happen? R is suppose 1 ohm, C is suppose 200 microfarad. Okay, then what happen? 1 into 200 microfarad, it will be a 200 microsecond of tau. It will charge, it will take another 200 microsecond to charge the capacitor. It will charge very high, very quick. That's why it will take a large amount of current at the same moment. If you know about the discharging also, it was discharging time, it will supply large amount of current in very less duration of time you can take in from them. Such as known as you know about the supercapacitor. At this time, supercapacitor is used. I think in research is given. Research ongoing on that supercapacitor. This one they are want to implement in the electric vehicle. Supercapacitor with battery, because the battery is the high power, sorry, high energy density device. This is the high power density. Okay, the high power device is the high energy. Battery is supply the current in large duration of time, but capacitor it will give a large amount of current in certain duration. Large amount of current have requirement when you want to start the battery, it's okay. But suppose you want to take a quick speed is going like 100 km per hour in 2 to 3 to 4 seconds, then what happen? It will requirement of the high amount of power at that time. It means the high amount of current in certain duration. The battery however time constant is greater than the supercapacitor time constant. Time constant of the battery is greater than the time constant of the supercapacitor. The battery will not provide the large amount of current in very quick, very less amount of time. It will take a time to to give the large amount of current. But in supercapacitor, it will provide the large amount of current in very quickly because of the time constant in microsecond. But battery time constant in millisecond. You take a time to discharge battery to start to discharge. Because the battery have not only this resistance, battery have an internal resistance also. capacitor have only a series resistance, internal resistance. Okay, then a question is asking the which type of battery statement is the two recording the SLI starting, lightning and ignition batteries. It means that they can be used for longer period. No, which one is used for longer period, that are known as the high energy type density battery. Which one used in the vehicle, which one used in the inverter, like that. It will be taken a certain amount of current, gives a certain amount of current, but the long duration of time. They can give a large amount of power for a certain duration. Yeah, that's one. Large amount of power, it means voltage is fixed for the both, but current high current. It will provide the high current for short duration of time. Next question, next option is given. They can give a large amount of power for a very long duration. No, they have low power density but very high energy density. No, same thing. This will the both same option. Low power density, it means a current duration is a current value is less, but it will give the large duration of time, 1 hour, 2 hour, 3 hour, 4 hour, like that. But this one, you know about the switching. If you take a self for a bike, that will quickly start. It will take a large amount of time at that moment. This one known as the SLI battery, which one used in car and bike. Okay, comes to the next question. For a particular application, the watt hour requirement is 500 watt hour. The selected battery has a nominal voltage of 12 volt and DOD of 15%, 50%. If the energy efficiency of the battery is 70%, then the capacity of the batteries. You know all about batteries capacity given in the AH, yeah, milliampere hour in your mobile, MAH, milliampere hour, and a large battery is a AH, and a very large battery will be kilo AH, KAH, it will be, because of the voltage is fixed in that moment. Written as the battery AH 100 AH, like that, 190 AH, it will means, so denoted the how much current we take for an hour. It will current and hour multiplication of this one is known as the AH, like that only. It means how many hours it will take to discharge the or fully discharge of battery. Okay, it will give the nominal voltage is fixed, 12 volt is given, DOD of 50%. Then what is the DOD? Depth of discharge, known as the DOD. Depth of discharge, it means how much by any battery it will discharge, how much discharge of your of our or capacity of it capacity, like that. All of you know about the mobile system. You use a mobile, suppose a 500 mAh battery is there, I can retain as 5 Ah, like that. It will be mentioned in your screen is 100% to 0%. Then you know about this, what is the 0%? It will be exactly 0% of a battery. It means battery is fully discharged at 0%. Our battery have some amount of power, some amount of energy also there when your battery is going to the 0%. That is known as DOD, depth of discharge. Depth of discharge, it means any battery how much it will discharge of its capacity. If any battery will discharge 100%, but it will not possible in practical cases. If you manufacture a battery like 100 Ah battery, then it will be give the 100 Ah also. in output. If you fully discharge any battery, then battery will damaged, may be damaged. That's why a battery, any battery who can't be fully discharged of any battery, in that moment what happen in your mobile, it given at 0%, the screen, but in actual it will be at 20% of your rated battery. SOC is 20%, it mobile or 30% like that. The 20% remaining charge is there also, but your screen shows at 0%. Then that's one is known as, it means your battery is discharged 80% and 20% is remaining also there. You can't be discharged this one. Only you can discharge the 80% battery only. You can, it means you can use the 80% of its capacity. You can't be use the 100% of capacity. That's one known as the DOD. That it means the DOD of that battery is 80%. SOC is different thing. DOD is different thing. SOC it means then how much charge is remaining there, and yes, DOD it means how much you can discharge the battery of its full rated battery. And if you want about the electric vehicle batteries, a cell, you know about lithium ion cell. A lithium ion cell is only 4 point maximum as a nominal voltage. You can say 3.7 volt is a nominal voltage. I was talking about the NMC cell. I'll explain you later what is NMC. Nominal voltage 3.7 volt. Low voltage, yeah, can say lower cutoff voltage. Lower limit voltage limit is 2.5 volt. Upper limit is 4.2 volt. This is the rating of a lithium ion cell, which is makes a battery by using a series and parallel connection. That battery is used in electric vehicle at this time. If you know about the electric vehicle, all of you know road electric vehicle, then that cell is usually this cell. That's cell voltage is 3.7 volt only. There is no any AC type of. This is the dry cell lithium ion cell. The nominal voltage 3.7 volt. If you use a 40, if you want to make a 48 volt battery, it means you should multiply of this one. 14 cell is used in this move. 14 cell is used to make a 48 volt battery. The lower limit is 2.5 volt, upper limit 4.2. It means you never discharge this limit of that cell. If you discharge below the 2.5 volt, then cell will damaged. And if you charge the 4.2 more than 4.2 volt, then the cell is also discharged. Its nominal voltage is 3.7 volt only. To make a high voltage battery, then connected in series. If you make the rating is 2.6 years. The rating is different. 2.6 years. Some is the 3.6 years also. Some another battery have a 4.4 years also. Para cell, single cell. This amount of rating is available in market, but now voltage rating is 3.7 volt. This phenomenon only for NMC cell. NMC is the type of the lithium ion cell, lithium ion battery. That's why they are required. But in the market, in battery, when you make a battery by manufacturer, a battery manufacturer, it will make the battery 3.7 volt. Oh, okay, nominal voltage. Maximum you take a 4.2 volt, but it will take a minimum is still will take in 3.2 volt only. This voltage is fixed, and in that voltage this will be give as the 0% SOC. and it will it will never discharge below this one. If you discharge 3.2 volt, it will go if you touch this touch the this limit, then associate shows the 0% associate like that only. This is the for the protection only, for protection of the battery. That's why DOD is never a 100%. They have a remaining charge, some charge is there. That's why DOD is have a parameter of a battery, which one you can select. For the lithium, for all of know about the lead acid battery. Lead acid battery have very poor in term of the DOD and capacity and density also. This 50% DOD, 50%, 60% is also in practical cases of the lithium lead acid battery, which one use the chemical. Another part, if you talk about the lithium ion cell and lithium ion battery, this one DOD is the 80%, 70%, 80%. Some of the cell is the 90% also, 85% DOD. You can discharge like that only also. But in lead acid, I have only 50% or 60%. Then comes on the question for a particular application at our requirement of 500 watt hour. It will requirement of total energy 500 watt hour. Voltage given at 12 volt. What is the AH capacity in AH? Simply watt hour divided by a voltage. This will be in AH. What is this one? 41.66 AH battery. It means 41.66 AH is required. This is the load requirement. But he asks about the battery capacity. Then battery has the battery parameters given a DOD of 50%. If the energy efficiency of the battery is 70%. Then what happened? First calculate the efficiency. Take an efficiency given as the 70% only. Suppose a 100% DOD, it means 100% it will charge discharge, but efficiency is 70%. Then what happened? How much used capacity of the battery? Then simply needed capacity 41.66 divided by of efficiency 70%, it will be 59.51 AH. This amount of battery is requirement when the DOD is 100%, but is given and the DOD is 50% only. It means you should use the double of this one. For 50% DOD, and what is the final capacity? One 19 AH approximately this one. Okay, just look here. Your required capacity is only a 41.66 AH watt support for the load requirement, but you need a final need the final requirement of the battery is 119 AH battery for the given the supply to the load which are requirement of 41.66 AH only. It means you need a better DOD and better efficient battery. If you use this type of battery, it means that this is the very well bulky. You use only 50% of your capacity of your manufactured battery. You use only 50%, not 50%. If efficiency is 70%, it means you use only less than 50%. That's why the lead acid battery is not regularly used in vehicle, electric vehicle, because of there is a very poor in capacity and DOD and cycles also. Cycle is not mentioned here. There is also cycles, how much in cycle it will be charged and discharged. But lithium ion battery is good for the electric vehicle at this time. But research is ongoing also. Another cell also is there, NMC cell. Another is the LFP cell. Which one is a better from NMC, but costly. Another cell sodium also. Research is ongoing that. So, question number third is SOC of a particular battery is 20%, then the DOD of the battery. For the 100% battery, it will at 20% SOC, then DOD is 80%. It will charge. But you can't be say directly 80%. This question is given in ideal cases. You can say this is the DOD of the 80%, but in practical case, some of the practical thing is applied like that. If you can't be discharged the battery, if you take a remaining of some power, some energy in the battery, then that one is known as the DOT. But in this case, SOC of a particular battery is given a 20%, then that DOD we can't be say directly 80%. But in practical, in ideal cases, in this question, you can say 80% because of the DOD is simply 1 minus SOC by 100 into 100 in percentage. But actual DOD is how much you can discharge a battery of its capacity, known as the DOD. The battery that is used in almost all electric gadgets nowadays. It means electronic gadget. It means mobile, laptop, video game like that. In this is the lithium polymer, lithium batteries. Lead acid, no. Lead acid battery is known as which one is the requirement of chemical like acid. There is no acid in your mobile battery. This is the lithium polymer, dry battery. Sodium sulfate, this is also, but it is not used in mobile. What is the lithium polymer? Next question given a consider a standard insulation and 50% efficient PV cells. Calculate the intrinsic area of PV panels required if the maximum power from PV panel is 1350 watt. Intrinsic area, it means how much area is taken, how much area is of a PV panel without any considering cleaning or another thing. It means how much area it will take for only a PV cells, PV batteries. Sorry, PV cells and PV panel to take it. It will take like we know about the P in input power of PV cells is area into insulation. This area is known. This area is the cells area only, which where the present PN junction is present like that for one cell, two cell like that. this area known as the insulation, PV cell area, and insulation is given as the standard insulation. Like this is a PV cell. This is the area, meter square in meter square. Calculate it, taken. Normal you can say P in like a total output power, output energy, the input power into hour, multiplication of the hour, how many hours is there, then efficiency, how much efficient of a cells is the output energy. If we talk about the output power, times P in into efficiency. Efficiency is given, output power is given, we calculate the P. Output power is 1350, efficiency is 15%, 0.15. And what is the P in? 9000 watts. P in, you know about the P in is the area into insulation. Insulation is a standard insulation in 1000 watt. Thousand watt per meter square, so 9000. Area is 9 meter square. There is a two area, instant area, intrinsic area, state. Intrinsic area, how much area is taken from the PV cell, a PV panel. State area means how much area is there in your you can say rooftop or anywhere which whenever presented PV panel, then taken a gap between two panels for a cleaning purpose. So there is some gap between them. If you including of that area also, then the final area is E state. It will be a 30% of area intrinsic. It will be keeping like that. If suppose a panel is here, then some panel is here also. Suppose this one the area is A, A into A, then total intrinsic area is 4A. But if you take in this area also for the cleaning purpose, then suppose this area is E, then for the E state area it will be 4A plus A. Then this is the final area it will take if you want to want to a PV panel to place on a rooftop or in a place, then that area is requirement to place the PV panel, total PV panel. But here is asking about the intrinsic area only. That's why it will be a 9 meter square. Next, the DOD of LiFo battery is around So I think lithium polymer battery, which one is your mobile and laptop, there is the 70% of depth of the discharge. It will be discharge the 70%. But lead acid battery have a very less, 50%, 60% like that. In practical cases, the cycle is also high for lithium battery. You can give a comparison of this one, like a lead acid battery, lithium polymer, sodium sulfate. What it means energy per kg, power per kg, and efficiency and cycle. DOD also here. Watt hour per kg. It is the energy density. How much energy density? This is the for the 50-35 watt. It will be 100 watt per kg. 100 watt, it means it will take 100 watt in a kg if you make a lead acid battery, because of it take a large of chemicals and platelets of the for making make the anode and cathode electrode. The efficiency of this one is 70%, approximate 60 to 70%. Cycle is 1000 maximum. DOD is 50 to 60%. Lithium polymer have 55 watt hour per kg. Energy 55. Wattage is same, and efficiency of this one is 80%, 70-80%. It will be 200 cycle. It will be charge. Cycle is means it's one time charge and discharge. It is known as a cycle. DOD of this one is the 70%. Sodium sulfate is also very high, 100 watt hour per kg. It will take a very less space also and less weight. This will be 150 watt per kg. Efficiency also good, this one 25% approximate. And cycles, it will be 1000 to 1500 like that. It will be also 70%. Oh, sorry, lithium polymer have a high power density. It will be 150, and this will be 200 watt hour per kg. Efficiency, okay, efficiency 80%. This is the cycle is 10,000. Sorry for this one, very high lithium ion battery. 10,000 cycle. It means you can charge and discharge 10,000 times. Data 70 to 80% DOT, very high, 80%. It's in space technology also lithium ion battery is used, because of there is also solar and web battery which is used in satellite. About satellite. There is also lithium ion battery which one life cycle is a 10 to 12 hour. years. Normal lithium-ion battery have a two cell NMC and LFP. LFP have a some costly. NMC have a 4 to 5 years, but this one is a 10 to 12 years. Both are the lithium-ion battery. Lithium polymer battery is very, you can say, very low amount of time, low power is used in like mobile and car starting and laptop battery like that. But lithium ion battery, which one is the LMC and MC cell, which is made by from the cell, a cell. Which cell is the 3.7 is the nominal voltage. Is the 4 to 5 years. And MC cell LFP is the 10 to 12 years lifetime. The very high. Consider PV system which will utilize the tubular lead acid battery. Tubular lead acid battery. Lead acid battery which will use the acid chemical for energy storage. The battery which has a nominal voltage of 24 volt is having a DOD of 80% and energy efficiency of 20%. Let the load energy requirement for the daytime and night time be 560 watt hour and 1120 watt hour. It is 560 watt hour is requirement in daytime and night time requirement of 11. I written here. Daytime is 560 watt hour and night time 1120 watt hour. The number of autonomous day and number of replacement day can be taken to be 0. Then the energy that we do storage has to store is in a battery. What is autonomous day? Autonomous day, it means how many days it will take, like a cloudy season in our area where is place PV panel. Suppose in a 30 day, like suppose in a month there's a 30 days, the power consuming like the 1 2 3 days is okay, but some days you have a cloudy season, there is no sun, there is no insulation, though no aeration. That means the PV power is 0 at that moment. Suppose for the some time, for 1 day 2 day like that, there is no sun, then this day is known as the autonomy days. The percentage is Na. And suppose in this day there here is the sun available, and you work like a load in daytime by the solar and night time by the battery. Okay, it's fine for here till the here is fine. But suppose 2 days the sun is not there. In that day, the only battery is there to provide the all loads, to give the supply to the all loads. But suppose after 2 days, suppose for 2 days only, their autonomous day is 2 days. Suppose after 2 days, if sun is there, sun is available, and solar is provided to the all, suppose full load. But there is a daytime, there is a load also in your homes, appliances like that. Then it will solar is give to the supply to the whole home appliances, and same time it will charge the battery also, because in 2 days battery is fully discharged. Then what happen? What you want to take a whole power in a day? If you want to take a whole charge the battery, a fully charge in a day, or 2 days, or 3 days, or 5 days, like that. Just depending on your solar power, a solar panel. If you place, if you take another large power of your solar, then you can charge the battery within a day. But taken it will be very costly according to the our loads requirement. That's why it will give in some amount of power in a day to charge a battery, but it will not requirement of to charge the battery fully charge the battery for from a single day. That's why it will take in some day to charge fully charge the battery. Suppose the 1 day, 2 day, 3 day, like that. 1 day, 2 day, or 3 day, 3 day, like that, to charge the battery, because of in where the no sun, then battery is fully discharged within a 2 days, 3 days, autonomy days. But same thing, if you want to charge a fully charge the battery, it will take a charge day. This is known as the day of recharge. Don't raise the NR. Who can be charged in single day. But in for the start the single day, it will requirement of very large panels. It will costly. That's why it take a 2 to 3 days. Maximum is a 2 days, taken a 2 to 3 days to charge the battery. And no sun is a on no sun, like that. If there is a no sun, it will maybe 2 days, maybe 4 days, maybe 10 days also in rainy season. But if you consider a many very amount of the day, like 4 day, 10 days, like that, then you requirement of a high power battery, high energy battery, a big battery requirement to provide the whole 10 days supply from battery. They are also costly. That's why in the consumer is taken only a 1 day or 2 days, all taken as the autonomy day for selection of a battery only. But in the question is given, but not considering the autonomous day, and replacement day is the like a recharge day. It can be zero for selection of a battery. But if there is a uh, autonomous day is there, then it will require the more capacity batteries. Then daytime have 560 watt is there. That power is delivered by from the solar only. There no need of a battery. And daytime battery will charge and all the load is delivered by the solar. In night time, solar is not available. In that time, battery is required and battery supply the to the load. But battery have a DOD of 80% and energy efficiency of 70%. First, to calculate the how much energy required of the battery to store without any considering parameter like DOT and efficiency. Required capacity for load, particular to the load only. Then what type? It will be 1120 watt hour. Night day only, night only. Daytime have a solar PV. It's even 1120 watt hour. If a 100% efficiency, 100% DOD, then you need only 1120 watt hour batteries. But there is a efficiency of 70% only. Then first calculate the efficiency. Well, 20 divided by 70%. 1600 watt hour. Next, having a DOD of 80%. After taking a DOD of 80%, then it will be go to 1600 divided by a 80%, 28. Then it will be a 2000 watt hour. If you consider the DOD also, if you consider not consider DOD, only if you want to take in the energy that the battery has to store energy. That storing in only it not given the supply also. It will give the storing the efficiency. Then you have to take only efficiency 70%. It will be 1600. If you consider DOD also, then it will be a 2000 watt hour. If you charge discharge, including the charge and discharge, this will be discharging time. DOD will be discharged only at 80%. You can't be discharged at the 100%. Then this will be a 2000. In the same question, if the energy that the solar panel has to deliver, solar panel has to deliver solar panel no daytime plus night time divided by battery efficiency. If the battery 100% efficiency, then whole baby has to deliver only daytime load and nighttime load. But there is not 100% efficiency. This will be the 80%, 70% efficiency. But you sorry, I think we consider the DOD also to select the battery. You consider the DOD also, not only a efficiency. Daytime is 560 watt, night time have 1120. If you take an efficiency only, that will be 0.7. Already consider the 1600 plus 560. But if you consider the DOD also, then it will be a watt hour day plus watt hour night DOD into efficiency. Then it will be 2560 watt hour. Watt hour, it means voltage also multiplication is there. If you divide by the voltage, then it will be in AH. In this question, what the ampere hour of a battery? We take a 1600 for a efficient battery, then multiply DOD into 24. Same thing, you can we have also calculated total power is 2000 divided by a total voltage 24, it will be 83 Ah battery. Is it the 2560 if DOD is considered here only. Next, in the question, if Na is 2, Nr is 5, then what our PP required will be? What our requirement, like we know about watt hour in day plus watt hour in night where battery efficiency plus. Suppose if NR and Na is 0, if Na is, suppose Na is there, it means autonomous day, like a 2 days, ID days, then it will be a totally off. Solar is not there, then it will be all of the energy should be stored in the battery also in daytime and night time both. Then if we store in battery, then watt hour in day requirement, this one the load for the load, and watt hour of load in night divided by a battery efficiency. Because of this power is also stored in battery for the autonomous day. In autonomous day is Na. Nr is 5. Nr it means how many days taking to the fully charge of a battery of that battery. Suppose in a single day, if you want to recharge this one in single day, that means a single set divided by 1. It means that amount of power should be stored in the battery. But if you want to take in this one for the 2 days, then this amount of power is very half of this one, something half of this one power stored in battery. If you want to require it for 3 days, then twice of this one. If you convert 5 days, there is a 5 day NR days, then NR is there. You take the NR days to recharge a battery. Then you can given this formula for autonomous day also. Day is given 560. This will be a 1600. If taken efficiency, this is a 560. This will be 11, 20. Divided by a efficiency 70%. This will be Na. Na is given as 2. Nr is given as 5. Night time is 11:20 only. Okay, then you can calculate total amount of power. 560 plus 1600, 11, sorry, 2160 plus 960 will 3120. What our requirement required. Next, the incident energy on tilted flat plate solar collector is 5 kilowatt hour per meter square per day. Given as HAT, kilowatt per meter square per day. HAT means the incident energy on flat plate collector with consider the effect of atmosphere. This is known as the HAT. If there is given HOT, it means it will be a incident energy on tilted collector without considering the effect of the atmosphere. But is given as the HAT, it means the how much incident on the flat plate collector. Sorry, tilted plate. Sorry, not given a plate. Tilted collector. Tilted plate collector. Solar collector. The efficiency of the plate collector, solar collector is 16%. So not a plate, tilted collector. Tilted plate solar collector is 16%. Total energy available from PV array is 25 kilowatt hour. Watt hour PV is given 25 kilowatt hour. Okay. Calculate the E state area in meter square and peak power of a day in kilowatt based on standard insulation respectively. E state area same thing 1.3 times of intrinsic area. First calculate the intrinsic area. Watt hour PV, this one will be input input what way efficiency into area into insulation. We consider in per day like HAT. This will be intrinsic area only. This one intrinsic area is given. Efficiency is given 60%. Area you have to calculate. HAT is given 5 and watt hour is given is 25 kilowatt. This one also kilowatt, then kilowatt cancel out 0.16 into I into 5. What is the intrinsic area? 25 divided by 5 divided by 0.16. 31.25. Area E state is given in the question. It will be 1.3 times of the intrinsic area. Sorry, meter square. Area in meter square. Next question is given. Calculate the state area in meter square and peak power of a day. What energy is given WHPV. WHPV means power into hour. 25 kilowatt per meter square per kilowatt hour per meter square per day. If you want to calculate the peak power, yeah, power, you can say power, total energy. Insulation is given as insulation is standard insulation. It means 1000 watt per meter square. You can say 1 kilowatt per meter square. But in total insulation is given total uh, the incident energy on tilted plate solar collector, that is 5 kilowatt hour per meter square per day in a day. It means what is the hour? How many hour? Consider this one as the standard 1 kilowatt per meter square, average of this one. Then how many hours? It will be a 5 hours, duration of 5 hours. That's why total watt hour PV watt hour is 5 hours into insulation is 1 kilowatt. This will be 5 kilowatt hour per meter square per day. In a day, it will be hour calculation is 5 hour only, because I have given is the standard insulation. With the 1 kilowatt is standard insulation, it will the total hour calculation is equivalent of 5 hours only. Then simply in energy divide by a hour, okay, calculate the power. 25 total watt hour energy divided by a total power is 5 hour. Then this is the 5 watt, not watt, this is a kilowatt. Kilowatt total power at, yeah, I think this so. Given as a standard insulation, but total hour total energy is in on the solar plate is 5 kilowatt hour. It means the 1 kilowatt is standard insulation, duration is 5 hours. That's why known as 5 kilowatt hours. And a battery has a capacity of 3C 120 Ah, where the C is the capacity rate, C rate. What is the maximum discharging current in ampere? Sorry, allow to the battery. Following C is equal to I into T, where T is the time, I is current, C is capacity of a battery, T in hour to make a AH, ampere hour. This is the hour, this is the ampere, ampere hour, capacity in ampere hour. The capacity is rated in ampere hour. You know all about the capacity in AH, and also it will be mentioned as parameter is in C rate, like 3C, 2C, C2, C by 2, C by 10, C10, C5. This is the rating of the capacity. Then this is denoted to the capacity, and this numbers are denoted to the hour time. This is the capacity, total capacity, this is the time. Then from this you can calculate the charging and charge or discharging rate of the battery. You can calculate this one from this one. Suppose there is a C5 notation. That's mean the battery, it will be fully discharged within a 5 hour of its capacity. Then what is the current rating? You can calculate. Suppose capacity is same 120 Ah. I will taken 120 Ah divided by a 5. It will discharge totally in 5 hour. From this one, then you can calculate the total current discharging current rating. It will be 24 ampere. It means 120 Ah by T, the discharging rate is 24 ampere. It means this is the maximum discharging current. C rate, it means given as the maximum discharging current rating. It means you can't be discharged from more than 24 ampere. Maximum current rating is 24 ampere. C5, if there is 5 or later after the capacity is or C2, it means divide by up to, it means all battery discharge fully discharged within 2 hours. Then what is the ampere? It would be a 60 ampere. If it discharge from 60 ampere, then total battery will discharge in 2 hours. Simple. If same thing is C 0.5, same you can divide 120 divide by 0 0.5, so 240 ampere. If you discharge from 240 ampere, then it will be discharged in half an hour. This can be denoted as C by 5 also. This will be a C by 2 also. This will be a C by 0 0.5 also. By it means a divided by this one. But this is the mentioning on the upper digit in right side of the capacity. But suppose there is in left side of this one, like 3C, 0 0.5C, 2C, then what happen? What is the meaning of this one? This was simply multiplication of the in capacity. Of 120, it will be a 360 ampere rating. You can discharge from 360 ampere. It means this will be denoted as the 1 by C3. The C divided by 1 by 3, like that. This will divide by the same thing. C divided by 1 by divided by 5. This will be also denoted as C2, like that. This C2 divided by 1 by 2. This will be kind of C 0.5. It means same thing you can retain as same thing from this one also. To calculate the current rating of a battery, is 0.5. Simply you can multiply 0.5 into 120. It will be a 60 ampere. Sorry. If 2C, then what point? 120 2 into 120, it will be 240 ampere. Then this is the C rating of a battery. If your left side is given, this is simply multiplication of the capacity. Then you can find the current rating. If a right side of the ear, then simply divide of that to the capacity. Then you can find the current rating of a battery. If you discharge very high rating of a battery, then the battery will discharge very, it will be cycle effect also. So very quickly discharge. Next, a PV array of rates at a standard insolation level of 3.5 hour in a day with a 60% efficiency. It supply power to an electric motor which drives a water pump to store the water in the tank. That means there is a solar panel. There is a motor connected to the shaft to the water pump. Water pump have a water reservoir here that will store the water on top of this water tank. So not like that. Height of this one is given. Think. Okay, this is PV panel. Drive electric motor. Electric motor soft is connected to the water pump motor. Then water pump have some reservoir, water reservoir. From this one, from the suction valve, it will take it, and water is stored in the tank by using a water pump, using a pipe like simply. Then a PV array operates a standard insulation PV level of 3.5 hour in a day. You can say what hour PV is what insulation standard insulation, it means 1 kilowatt per meter square. For 3.5 hour, it means 1 into 3.5 hour. Then watt hour PV is 3.5 kilowatt hour per meter square per day in a day. Okay, with 16% efficiency. Then multiplication of 60% also. It supply power to an electric motor, simple motor, which drives the water pump. Okay, to store the water in a tank installed at a height of 10 meter. Okay, this is the 10-meter height. This all of is the in ground level. Motor has 88% efficiency. This will be 88% efficiency. Pump has a 92% efficiency. Ignore the losses in a branches path. It means during the this one for the energy flow. Following the standard insulation for a given time, what is the expected energy in megajoules stored in the water tank? Intrinsic area also given is 2.25 meter square of a PV panel. It means total area is 25 meter square. Sorry. Efficiency into area into HAT. The total solar power. Efficiency is given 16%, area is 25, HAT is given 3.5. 3.5 is been 1 kilowatt per 3.5 hour. Then what is the total watt hour power? This power is calculated for a panel area is 1 meter square per because of the this is taken as a 1 area. If there is a 25 meter square area, then multiplication of 25. Simple. Point of 16 into 25 into 3.5 is equal to 14 kilowatt hour per day. In a day, the solar is supplied, the total energy is to 14 kilowatt hour in a day. Now, what is the output? Watt hour in output. What is the output power? Same power, this will generated as a 14 kilowatt here given to the motor, and motor have a 88% efficiency. Then what is the here? What is the here power energy? It means a 14 kilowatt hour into efficiency. Efficiency is 88% only. Then 0.88 14 into 0.88 12.32 output of a motor. Taken an output of a motor. This will be 12.32. Energy. Then what is the output of this one? This energy into my efficiency. Then this finally is 11.33 kilowatt hour. Watt meter watt power output of a water pump. 12.32 into 90% efficiency 11.33 in a day. Next, it, then how much energy stored in a water tank? Also given as the losses of in transmission line is 0. That means the same energy transfer 11.33 kilowatt to the water tank. But it is asking about in megajoules. But our estimation in kilowatt hour. Then it should convert this much energy in joules. Then what happens? 1 watt is equal to the 1 joule per second. 1 watt hour is equal to 1 joules per second. Both are the energy parameters, units, joule per second. Sorry, 1 watt, joule. 1 watt is also in power rating, joules per second. Joule is energy unit. Divide by energy, divide by time. Then what happened? This one is power. If energy divided by time is power. Same thing, joule divided by second. And 1 watt is equal to 1 joule per second. Because joule is energy unit, but divided by second or divided by time, energy divided by time is power. Both are power unit. 1 kilowatt, same thing, 1 kilojoule per second. Same multiplication. If you multiply 1 kilowatt hour, then what happened? This is the energy, then 1 kilojoule into for the second multiplication of 60 divided by 60 in second is minute, then divided by 60 is in hour. 3.6 megajoule. This will be 1000 into 60 into 60. It will be a 3.6 megajoule. 1 kilowatt hour is equal to 3.6 megajoules. Then what is the total energy transfer from the solar pump to the storage tank? Storage is 11.33 kilowatt hour. Simple. 11.33 multiplication of 3.6 will be 40.78 megajoules of energy transferred as stored in a tank. What is the maximum capacity of overhead tank in kiloliter for the given data? Question: 1 liter is equal to 1 kg of water. It will not actually is equal to this one, but in given question 1 liter is equal to 1 kilowatt capacity. Okay, then what will do? We have a megajoules energy, total stored energy, actually 1 joules is equal to, it will be a 1.0.10197 kg. It will in terms of force meter. This will be force. It will be total force is also term of energy. This will be kg meter. In terms of force, kg meter. Then what happened? For 40.78 megajoules, then simply 1 joule is equal to this one. Then what is this one is equal to 4 0.78 into 0.10197 kg meter. It will be 4.16 kg meter. It will be mega, then it will be mega kg meter. Mega it means 10 to the power 6, and head is also given is a 10 meter of head. Height of tank is 10 meter from height of a tank is given. So not for this one, height of tank, it means this one is given 10 meter. Right. Then what is the total kg of water? For 1 meter is given, it will be a 4.16 mega kg. Then for to 10 meters, if a head is given as 10 meter, then it will be 4.16 into 10 to the power 6 divided by of 10. 4.16 into 10 to the power 5. It will be 416 kg. This amount of 4 kg is be stored in a water tank. Don't be confused here how I divide the 10. 1 meter is given as this one. 4.16, then 10 meters is simply multiplication of 10, but I divide by 10. Why? Because of here it will be not 4.16 mega kg per meter. It will not given per meter. If then per meter, it means 1 meter is equal to this one. For 1 meter is this amount of, but it is not given a per meter. This will be kg meter. That's why it should be divided by of 10. If we increase the water head, then this will be decreasing the total kilogram. Another question also here. The load profile of a small load in a day is shown below. What is the average load in watts per day? Total load is given. The 0, it means 12 midnight, 6 a.m. here, 12 noon, then 3 p.m., 6 p.m., then 12 midnight. And average it in 24 hours. Average load is total load divided by total time, the total hours. So total is load is given here. This is the load profile. Calculate according to this 100 watts for a 6 hour 0 to 6 plus 80 watt for 6 to 12, it means 6 plus 150 watt for 3 hours, this duration. Then for 3 hours it will be 120 watt. Then again 80 watts for 6 hours. By a 24. Simply calculate this. 100 into 6 plus 80 into 6 plus 150 into 3 plus 120 into 3 plus 80 into 6. Then it will be a average load of 98.75 watts per hour, you can say. It's average load. A battery 24 volt has to be sized for fulfilling the load profile shown in question 17. Calculate the ampere hour required for the battery. Because in the DOD is 80% and energy efficiency of load is 85%. The watt hour for a battery, the watt hour for load divided by efficiency. It will efficiency of the load. Of load is given. Then calculate total hour. This one total load. First calculate the total load. 100 into 6 plus 80 into 6 plus 150 into 3 plus 120 into 3 plus 80 into 6. It will be 2370 watts. Efficiency is load is 85%. It will be 2788.23 watt requirement to the loads. Then ampere hour of battery total load it should be delivered by the battery 2788.23 a 24 volt battery Ah, then what is there, then divided by 24 into DOD is given 85%. You can calculate this one. Two seven eight 23 divided by 24 divided by 0.85 136.67. Yes, or you can say you can take this amount of in the middle range is not available in market, then you can say this will be approximately 150 Ah. You have to choose the 150 Ah battery for this LED and voltage is 24 volt to supply to the load. Then which is the suitable for C rate of the batteries? Discuss in question number 17. I think 16. And previous question is asking about the what is the suitable for C rate. To calculate the C rate and how to happen. First calculate the maximum current which will taken from the load. First calculate the maximum load. Maximum current taken from 150 by loads. At that moment, it will take the maximum current from battery. First calculate I max 150 watt divided by 24-volt battery is there. Then it will be a 6.25 ampere. Now, which C rate is there to or AH is 150. Then you can say C10, C20, C15 and C2 like that is there. This type of C rating in the available in the market. C5 also. C1 also is there. C1 is very high current rating. C10 it means 150 divided by 10, 15 ampere current rating. 150 divided by 20 it will be 7.5 ampere rating. 150 divided by 50 it will be a 10 ampere rating. 150 divided by 2 it will be 25 ampere of current rating. 150 divided by 5 30 ampere rating, but your maximum current is 6.25. And how will you choose this amount of current? Don't really. You can choose this one from this one, this one. If you anytime you want to take in a more load, then you can take 10 ampere, or you want to reduce the cost of the battery, then take this one 7.5 ampere C20 suitable for this load. Okay, everyone, I want to stop here. Thank you, all of you.
Thank you, sir.
Okay, welcome.